Welcome, ladies and gentlemen, to some more completing the square examples. If you're having trouble with the assignment that we've posted, go and follow along, and I will try to make this as painless as possible. So remember, completing the square, it will be used primarily for quadratics that cannot be factored, and a couple of other conditions will need to pan out, and I will summarize those in another video. But from this problem here, we're going to do completing the square. It'll be a pretty fast example. We'll just do 5 of these in total. So first thing I'm going to do is I'm going to go and add 3 to both sides. And again, I'm doing this because this quadratic is not factorable. If it was factorable, I would just factor it, but it's not. So we're going to do a different technique on it. From here, I'm going to add the box on one side. And if I add the box on the left side, I have to add the box on the right side. The number that goes inside the box is always half of the middle term. Half of the middle term would be half of 8. So half of 8 is 4. And now from here, using the shortcut, I'm going to go and pull 1x and 1 4 from the box. And since that 4 on the inside is positive, they will be added together. And then this will be the hard side, so this will become 16 plus 3 will be 19. I'm going to take the square root of either side to give me x plus 4 is equal to root 19. Don't forget your plus or minus. And if I subtract 4 from either side, I will get x equaling negative 4 plus or minus root 19. The root 19 can't be simplified, so I will not simplify him. And then I will separate my answer. Negative 4 plus root 19, negative 4 minus root 19. Now again, I'm going to require you guys to do that just this week. After this week, you guys don't have to do that anymore. But I just want to make sure we are aware that these are 2 separate answers. Cool. All right, let's do another one. Kind of in a similar vein. So the next one is x squared minus 14x plus 10. And again, not factorable. So I'm not going to factor this thing. So I'm going to go ahead and just subtract 10 from both sides, just like we did last time. We subtract the last term over. We get x squared minus 14x. I'm going to leave myself space because, as you know, what we're going to do inside this space is add the box. And on the right side, I will also add the box. Now, the number that goes inside the box is always, again, half of the middle term. Well, what's the middle term? The middle term is negative 14, so I'm going to throw down a negative 7. I'm going to be as literal as possible. And the reason why I'm doing that is because then on the shortcut, I can pull 1x in, 1 negative 7 in, and then I'm done with the easy side. The hard side, on the other hand, here, we're going to multiply that together, so we get positive 49. 49 minus 10 is 39. So I will go and square root either side. X minus 7 is equal to plus or minus root 39. There's not a whole lot that can break this thing down, so we're not going to. So I'm going to go and add 7 to either side. So I get x equaling 7 plus or minus root 39. And again, I'll go and separate that out into 7 plus root 39, 7 minus root 39. And there's our answer. So let's go ahead and clean up the board, and I will come back with 2 more examples. Alright, so here comes example number 3. X squared plus 2x plus 7 is equal to 0. Now I want you to pay special attention to this one. This one's going to be a little bit unique among the others. I'm going to go ahead and subtract 7 from either side. I get x squared plus 2x, leave myself space, getting negative 7. And I'm going to add the box on either side. Well, what goes inside the box? Well, what goes inside the box is always half the middle term, right? So half the middle term is 1. So what I get is, using the shortcut, I get x plus 1 squared equaling, here's a problem. Negative 7 plus 1 is negative 6. When I go to initiate my square root, I get x plus 1 is equal to plus or minus root negative 6. But there's a warning here. There's a warning. Warning. The square root of negative 6 does not exist in real numbers. So that's why when I take the square root of negative 6 right here, this is actually not what we would write down. We wouldn't even write this thing down. We would go back to here and write no solution. So keep that in mind, guys. Because we can't take the square root of a negative number, we will call this thing no solution. Now that actually has a pretty big graphical implication, and I will get into that when we start talking about graphs of parabolas in more detail. So here comes number 4. Number 4 is going to be a little bit more trying. X squared minus 3x minus 20 equals 0. And I think you can tell why it's going to be a little more difficult. It's this middle term right here. But regardless, if I'm going to do completing the square, I'll go and add 20. X squared minus 3x, leave myself space, equals positive 20. And now I'm going to add the box. Now, if you remember from yesterday's lesson, why we drew the box on the right side and left side this way will be very important. It's because this will end up becoming a fraction, because half of negative 3 is negative 3 over 2. So the shortcut makes the thing easier, because all I have to do is just bring this down, square it, slap on an x, slap on a negative 3 halves, and then you're completing the square is almost done. Equals, this is going to be a little bit harder. This is 20 plus negative 3 squared is 9. 2 squared is 4. I'm going to need a common denominator here to add those two things together. So what does that look like? Well, 20 is really 80 over 4 plus 9 over 4. That gives me 89 over 4 equaling x minus 3 halves squared. And from here it's all downhill. I'm just going to go and square root both sides here. So I get x minus 3 over 2 is equal to plus or minus root 89, whoops, not 81, 89 over 4. Now this expression right here can actually be simplified a little bit, because taking the square root of 89 over 4, let's scroll down here real quick, the square root of 89 over 4 is equal to the square root of 89 over the square root of 4. This 4 can become a 2. So what I really have here is I really have x minus 3 over 2 is equal to plus or minus just the top square root of 89 all over a 2 that has been freed from the square root. And now I'm going to go and add 3 over 2 to both sides and finalize the problem. So I get x equaling 3 over 2 plus or minus root 89 over 2. And I'm not done yet. I'm going to go and simplify this. I'm going to expand out the answer. So I'll say x is equal to 3 plus root 89 over 2 for the positive version, and 3 minus root 89 over 2 for the negative version. And that wraps up number 4. Let me clean up the board again. We'll tackle the most difficult one, number 5, and then we'll be done. And here we are with number 5. So obviously this one's going to be harder because of this 2 hanging out here. Now actually I would be inclined to do the quadratic formula on this one, but I do want to get you guys practice at completing the square. So we will do completing the square for this one. So subtract the 3 like we always do. 2x squared minus 16x, leave myself space, is equal to negative 3. Now if you remember the rules of completing the square, they say that in order for a quadratic to be completing the square worthy, the leading coefficient has to equal 1. Right now our leading coefficient does not equal 1. It equals 2. So I'm going to factor out that 2. I get x squared minus 8x, leave myself space, equals negative 3. Now I'm going to go and add the box to either side. But remember, whenever there's a coefficient out here, that coefficient interacts with this box by multiplication. So this box will need to get multiplied by a 2 for balancing purposes. And then inside the box, half the middle term, negative 4. So now from here, I'm going to get 2, and then the easy thing, 1x, 1 negative 4. Equals, this is going to take a little work, so that's going to be 16 times 2 is 32, minus 3 is going to be 29. So now I'm going to go ahead and divide both sides by 2. And this problem is going to be rather ugly, but that's okay, we can deal with that. It's going to be x minus 4 squared is equal to 29 over 2. I will square root both sides. Now, unlike the last time, I will not be able to square these things individually because 2 is not a perfect square. So what I'll do is I will leave him as plus or minus with a large radical of 29 over 2. And then I'll just add 4 to both sides. Now, down the line, you're going to learn a technique known as rationalizing the denominator, but since we're not there yet, I won't worry about having you guys do it. So this will become 4 plus or minus root 29 over 2, or 4 plus root 29 over 2, and 4 minus root 29 over 2. And I think that will wrap it up for the completing the square extra practice. So if you need to, go and rewind and see where things aren't making sense, and we will see you guys on Wednesday.